Alright, so this section just doesn't end. We're hopefully more than halfway through it, but I'm worried that some of the problems have a little more work to do, and we introduce a new concept in the last few problems. So the next group of problems, 33 through 40, want me to find the derivative, and there's a fraction with an x in the denominator. That doesn't work so well for the power rule. The nice thing about these problems is the denominator just has a single term, and I can follow the instructions, rewrite the problem without a fraction. Really, it means rewrite a problem so there's not an x in the denominator of a fraction. They might have fractions in terms of numbers, but the x can't be in the denominator of a fraction. So to rewrite the problems kind of how I envisioned doing this problem, I need to make my fraction into 3 fractions because the numerator has 3 terms, and we can always rewrite a fraction by taking each term in the numerator and writing it over the entire denominator. And when the denominator just has 1 term, that's a real productive thing to do. Now I'm going to reduce. First fraction reduces really nicely. 4 over 2 turns to 2. And on the x's, you subtract their exponents. The x in the denominator has an exponent of 1, and you're going to get an x squared. Second fraction, the 5 over 2 doesn't reduce, so I'm going to leave that 5 over 2 alone. And for the x, I'm going to subtract their exponents. I'm going to get an x to the first power, and I'm going to write that instead of in the numerator to the right of the fraction. Third fraction doesn't reduce. I'm going to move the x out of the denominator, and instead of up to the numerator, I'm going to move it in front of the fraction. And when I do that, I need to change the sign on its exponent. It has an exponent of x to the first. I'm going to change that to x to the negative 1. So that's the rewrite that you need to do for problem 34. Your rewrite for 33 is a little bit easier. Now I can take the derivative. F prime of x is going to be 2 times 2x to the 2 minus 1 plus 1 times 5 halves x to the 1 minus 1 plus negative 1 times 3 halves x to the negative 1 minus 1. That's just using the power rule 3 times. This is going to give me f prime of x equals 4x to the first power plus 5 halves x to the 0 power minus 3 halves x to the negative 2 power. Now I'll clean this up. First piece, I don't need to write an exponent of 1, so I'm just going to write 4x. Second piece is 5 halves times 1, so it's just plus 5 halves. Last piece, I don't want a negative exponent. I need to move the 2 down to the denominator of that fraction and get a 3 over 2x squared with a minus sign in front still. Because I did plus minus right there, and that gave me a minus 3 halves. Alright, your 33 is easier, so give us a go at that. 35 and 36 are a little bit tougher. Your 35 is a little bit easier than my 36. I need to rewrite this problem so it's not in the form it was in. I need to write it as separate fractions, and so I'm going to rewrite each one of these terms in the numerator over the denominator. Need to make the radical into fraction exponents, and cube roots are going to be 1/3 powers. The first fraction, its numerator has an exponent of x to the first, and I need to make that x to the 3/3. So I'm doing lots of little algebra tricks here, and your algebra skills, if they're not what they should be, will get real good really quick, because we just kind of do the same tricks over and over, and you'll get used to them. So now I'm going to subtract the exponents on the first one to get rid of the fractions. 3/3 minus 1/3 is 2/3. The second x to the 1/3, I'm going to move up next to the 2 and make its exponent negative. Now I can do the derivative. So I took 3 or 4 steps to rewrite the problem, and you're going to have to do something similar for 35. Now I'm going to use the derivative, so I'm going to write y prime as 2/3 times x to the 2/3 minus 1. Notice I didn't put a 1 in front of the x there and write 2/3 times 1, because you don't need to do that. Plus negative 1/3 times 2 x to the negative 1/3 minus 1. So that's going to be y prime equals 2/3 x to the 2/3 minus 3/3, 1 can be written as 3/3. And then this piece right here is going to be minus 2/3. And then I have x to the minus 1/3 minus 3/3, because 1 is equal to 3/3. So that's going to give me y prime equals to 2/3 x to the negative 1/3 minus 2/3 x to the negative 4/3. Again, I'm not explaining every bit of arithmetic, because at some point I just can't. Otherwise, I mean, the videos are ridiculously long. They're going to get insane if I try to explain every bit of algebra that I do. And you'll just get used to it. The more you do, the more you watch me do this, the better you'll get at it. Now I'm going to make the exponents positive on the radicals, or on the fraction exponents, by moving them down to the denominator. So I move the x to the negative 1/3 and the x to the negative 4/3 down to the denominator. Now I'm going to write radical notation, because the initial problem was in radical notation. This would be a fine answer. I don't need that exponent of 1 there, but it's okay. All right. So you should give 35 a crack. It should work the same way. 37 and 38 are kind of grown-up versions of this problem. They're even a little bit harder, but they're basically the same. So 37 and 38 start with a fraction that has a single term in the denominator. I need to rewrite it. So I'm going to write x squared over the cube root of x plus 5x over the cube root of x plus 21 over the cube root of x. The cube root of x is x to the 1/3 power, because it has an exponent of 1, and you take the index and write it under that. And for the exponent of 2, I have to think of that exponent as being 2 over 1 and multiply it by 3 over 3. So I'm going to rewrite the first fraction, both the numerator and the denominator. I'm going to write its exponent as x to the 6 over 3, because 6 over 3 is equal to 2. To change an integer into a fraction, you write it over 1, and then you multiply it by what you need the denominator to be. First denominator is going to be x to the 1/3. In the second fraction, the x in the numerator is equal to 1, and I need it to be 3 for the denominator, and 1 is equal to 3/3. Same thing, I could say 1 over 1 times 3 over 3. I can rewrite the 1 as 1 over 1 and then multiply it by 3 over 3 to get the 3/3. And then the last one, I don't need to do anything to the numerator. Now I'm going to subtract the exponents. First fraction, 6/3 minus 1/3 is 5/3. Second fraction, 3/3 minus 1/3 is 2/3. Third fraction, no subtracting, but I bring the x up to the numerator to make its exponent positive. Now I can take the derivative. I'm going to get f prime of x. And the first one, it's going to be 5/3 times 1, which is just 5/3. X to the 5/3 minus 1. But instead of my minus 1, I'm going to write minus 3/3. Second derivative, I'm going to go 2/3 times 5. X to the 2/3. Instead of writing minus 1, I'm going to write minus 3/3. And then plus negative 1/3 times 21 x to the negative 1/3 minus 3/3. Clean this up now. I get f prime of x equals 5/3 x to the 2/3 plus 10/3 x to the negative 1/3 minus, because the plus times the minus gives me a minus. The 3 cancels with the 21. The fraction goes away because the 3 turns to a 1. The 21 turns to a 7, so I get minus 7. The exponents have the same sign, so I add the 1 and the 3 and get x to the negative 4/3. Now I'm going to make my negative exponents positive, so I'm going to get f prime of x equals 5/3 x to the 2/3 plus 10 over 3x to the 1/3 minus 7 over x to the 4/3. So there was a reason in beginning algebra they taught you how to work with the negative exponents, and where in intermediate algebra they taught you to work with the fraction exponents. I'm going to make the fraction exponents and the radicals, and for my answer I'm going to get f prime of x equals 5/3 times the cube root of x squared plus 10 over 3 times the, heck, let me get another sheet of paper here. So I'm going to get f prime of x equals 5/3 and then the cube root of x squared for the first piece, and then plus 10 over 3 and then the cube root of x to the first, which you don't need the exponent of 1 for the second piece, and then minus 7 over the cube root of x to the fourth. And that would be the best answer for problem 38. This radical reduces, but I'm not going to reduce radicals so much in our class. 40 is exactly the same grunge, and I want to get into the second part, so I'm going to skip 40. Hopefully you can do 39. It's just a repeat of the same tricks. And I'll get up to 52 for the next group of problems. These are good. So there's a part A and a B. I maybe should have written a part A, B, and C, because for each of these you're going to have to take the derivative. So part A says find the slope of the tangent line, and to find a slope of the tangent line you take the value of x and plug it into a derivative. To find an equation of a tangent line we need a point and a slope, and we'll work on getting that here. So for each of the problems between 43 and 52 we're going to start off by finding the derivative. The derivative in problem 44 is going to be 2 times 2x to the first minus 1 times 6x to the 0, and then minus 0. Derivative of a constant is 0. So I'm going to start doing a little bit less work in my derivatives and start doing some stuff in my head, because usually students can do that pretty quickly. So the derivative of the problem in the function in problem 44 is going to be 4x minus 6. To do 44a, to find the slope of the tangent line at the value of x that's given, so the slope of the tangent line you get by taking the value of x and plugging it into the derivative. So that's what I'll do. So I have a slope of a tangent line, and that's part A done. So this is part A. Slope of the tangent is m equal to 6. Now I'll move on to part B. Part B says find an equation of a tangent line. Well, we did equations of tangent lines in the last test. And in order to do an equation of a tangent line, we needed a point and a slope. Well, the slope is going to be 6, and the point has an x-coordinate of 3, and what we did in the last chapter we'll do again in this chapter. To get the y-coordinate of the point, we'll take the value that's given and plug it into the original function. Plugging numbers into a derivative gives me a slope. Plugging numbers into the original function gives me a y value of a point. So to get, I'll use this to get this y value. I'm going to go 2 times 3 squared minus 6 times 3 minus 2, which is going to be 2 times 9 minus 6 times 3 minus 2, which is 18 minus 18 minus 2, which is minus 2. So in part 44b, where I'm asked to find an equation for a tangent line, I need both a point and a slope, and I was only given the x-coordinate of the point. I got the slope by plugging the x-coordinate of that point into the derivative. I got the y-coordinate of the point by plugging the x-coordinate into the original function. Now I'm going to do my equation of my line. I'm going to go y minus y1 equals m times x minus x1. That's going to give me y minus negative 2 equals 6 times x minus 3. Gives me y plus 2 equals 6x minus 18. Then I go minus 2 minus 2. My answer for 44b, the equation of the tangent line is y equals 6x minus 20. So the two parts to 44a, that part A, find the slope of the tangent line is 6. Part B, find the equation of the tangent line, it's y equals 6x minus 20. You should be able to do problem 43. It's just the same sort of problem. Now we'll move on to 46, which is much grungier. So I need to find the derivative to do part A and to do, really just for part A. So for part 46 beginnings, I need to rewrite this so I can take the derivative. So I wrote the fourth root of x as x to the 1/4 power, and now I'm going to do the derivative. So I get g prime of x equals 1/4 times 12 x to the 1/4 minus 1, but I'm going to write minus 4/4 because 1 is equal to 4/4, plus 1 times 3 x to the 1 minus 1, and the derivative of a constant is 0. So I'm going to get g prime of x. A fourth of 12 is 3. Then I get x to the negative 3/4 plus 3 times x to the 0. This is going to give me g prime of x equals 3 over x to the 3/4 plus 3 times 1. This gives me g prime of x equals 3 over the 4th root of x cubed plus 3. Now I can do part A. To do part 46a, I want the slope of the tangent line, and the slope of the tangent line at x equal to 16 is going to be g prime of 16, which is 3 over the 4th root of 16 cubed plus 3. I could do that without my calculator, but I'm just going to use my calculator. I'm getting worn out right here, so I'm going to pull my calculator out and do this on my calculator. Make the answer into a fraction. So I'm going to go clear 3 divided by parentheses 4 for the 4th root. Then I hit the math key, go down to option 5. That now it's going to hit enter. That's how you do the 4th root on this calculator. And then parentheses 16 exponent 3, close my parentheses. One more close parentheses. That's 3 over the 4th root of 16 cubed. Now I'm going to tack on the plus 3. It's going to give me a decimal. And to turn a decimal into a fraction, you hit math and enter twice. So I'm going to hit math and then enter and enter. So I get 27 over 8, which would have been doable by hand, but I didn't care to do it. So the answer to problem 46a, the slope of the tangent line is m equals 27 over 8. Now I'll move down and do part B. Part B wants me to find the equation of the tangent line, and I have almost everything I need. I have the x-coordinate of the point, I have the slope, I'll need the y-coordinate of the point. So I'm going to finish this problem up. So moving on to 46b. So for 46b, I need a point and a slope. The slope of the tangent line is 27 over 8. And I need a point. The x-coordinate of the point is 16. For the y-coordinate, I go 12 times the 4th root of 16 minus 3 times 16 minus 4. I could do that on my calculator if I can't do that in my head. I can do it in my head, but I'll do it on my calculator. So I'm going to go clear 12 parentheses 4 math, go down to option 5, 4th root of 16. I'll go parentheses 16 parentheses, and then close the parentheses again. That's the first part, and then I do minus 3 times 16, and then minus 4. I get negative 28 for the y-coordinate of the point. Good thing, so now I have the slope and my point, so I'm going to use y minus y1 equals m times x minus x1. I'm going to go y minus negative 28 equals m 27 over 8 times x minus x1, which is x minus 16. This gives me y plus 28 equals, I'll go 27 over 8 times x. And then 27 over 8 times minus 16 is actually easy. So when I go 27 over 8 times minus 16, I'm going to cancel the 8 with the minus 16. The minus 16 will turn to a minus 2. The 8 will turn to a 1, so my fraction will be gone. I just multiply 27 times minus 2, which is minus 54. Finish up the problem now for solving for y by minusing 28 from both sides. And I'm going to get my answer for part B. On the left side of this equation, I have a y. On the right side, I have 27 over 8x, and then minus 82. So that's the equation of the tangent line. So you should be able to do the same for problem 45. I don't know if it's a little bit harder because you have 2 radicals and I only have 1 radical. Alright, a few more problems and then we'll break for the part 3 of my video. So, first step for each of these problems in the 40s here, I need to get the derivative. In order to get the derivative, I have to rewrite the problem so it's ready for a derivative. So I moved this x and that x squared up to the numerator, made their exponents negative. Now I have the problem rewritten as f of x equals 2x to the negative 1 minus 3x to the negative 2 plus 5x to the first. Now I can do the derivative. Done. And so the derivative is going to be negative 1 times 2x to the negative 1 minus 1 minus negative 2 times 3 x to the negative 2 times 1 minus 1 plus 1 times 5x to the 1 minus 1. So I get f prime of x equals negative 2x to the negative 2 plus 6x to the negative 3 plus 5x to the 0. So this is going to be f prime of x equals negative 2 over x squared plus 6 over x cubed plus 5. Now I can do part A, and I'm going to use my calculator because I'm feeling lazy. So the slope of my tangent line is going to be f prime evaluated at negative 3. It's going to be negative 2 over negative 3 squared plus 6 over negative 3 cubed plus 5. All that's going to be done on calculator. I don't care if you use your calculator to do basic arithmetic. It's completely fine. So I'm going to go negative 2 divided by parentheses negative 3 squared, and then plus 6 divided by parentheses negative 3 up arrow 3, and then plus 5. Enter, ugly decimal, math, enter, enter. I get 41 over 9 for my slope. Does that make sense? Another calculator that I like so much better. I think that's fine. Let me do it on this calculator real quickly. So I'm going to go fraction negative 2 over negative 3 squared plus fraction 6, you can't see it, 6 over negative 3 cubed plus 5 plus 5. Yeah, 41 over 9 is perfect. So the slope is 41 over 9. So for 48a, the answer is my slope is 41 over 9. For part B, I need to get an equation. So for part 48b, I need, hopefully that was all readable. For 48b, I need a slope, which is 41 over 9, and I need a point, and the x-coordinate of my point is negative 3. I'm going to get the y-coordinate by plugging in negative 3 for these x's that you can barely see anymore. So the y-coordinate, I'm going to go 2 over negative 3 minus 5 over negative 3 squared plus 5 times negative 3. That's going to the original function, changing the x's to negative 3. And again, I'm just going to use my calculator to get the y, so I'm not feeling so motivated to do those fractions by hand. So 2 divided by parentheses negative 3 minus 5 divided by parentheses negative 3 squared plus 5 parentheses negative 3, and then math, enter, enter, and that's negative 146 over 9. So you can definitely exploit your calculator to do just basic arithmetic that you don't care to do by hand. I don't want to bog you down with the calculus is enough work, and adding and subtracting fractions using your calculator is completely legal. So now I'm going to find the equation of the line going y minus y1 equals m times x minus x1. That's going to give me y minus a negative 146 over 9 equals 41 over 9 times x minus a negative 3. Have some double negatives I need to make pluses, so I get y plus 146 over 9 equals 41 over 9 times x plus 3. This is going to give me y plus 146 over 9 equals 41 over 9x. And when I do this multiplication, the 41 over 9 times 3, I'm not going to cancel like I might normally, because this fraction has a denominator of 9. I want to keep this denominator of 9. So I'm just going to multiply those two and get plus 123 over 9. Because that's going to make it easier when I do this now. Now I'm going to go minus 146 over 9 minus 146 over 9. And you're going to get minus 23 over 9. So I'm going to get an answer of y equals 41 over 9x minus 23 over 9. A few more problems and I'll pause this part of the video and then we'll go on to the part 3 of a video. Alright, so 50 doesn't look near as bad as the last problem, but 52 looks horrible. So let me see what 50 goes. So first I need to find the derivative. So I'm going to rewrite the problem as 3x to the negative 2. Now I'm going to find the derivative. Y prime equals negative 2 times 3 x to the negative 2 minus 1. So y prime is negative 6x to the negative 3. Y prime equals negative 6 over x cubed. So I needed the derivative so I could find the slope. The slope of my tangent line at x equal to 3 is going to be negative 6 over 3 cubed. That's negative 6 over 27. And that reduces by 3 to negative 2/9. So for 50 part A, the slope of the tangent line is m equals negative 2 over 9. For part B, I need the equation of the tangent line, and to get an equation of a tangent line, I need a point, and I need a slope. I know that the slope is m equals negative 2/9, and I know the x-coordinate of the point is 3 because that was given in the problem. To get the y-coordinate on the point, I just plug 3 in for that x. So the y-coordinate is going to be 3 over 3 squared, which is 3 over 9, which is 1/3. I don't know if I should have left it 3 over 9 because of the 9 there. But that's where I'm leaving it now. So in a second, I'll find the equation of the line. There's your problem 49 that you're going to need to do in a minute. So now to get my answer, I'm going to go y minus y1 equals m times x minus x1. That's going to give me y minus 1/3 equals m, which is negative 2/9, times x minus 3. It gives me y minus 1/3, and then I go minus 2/9 times x. And then I have to go minus 2/9 times minus 3. And when I do minus 2/9 times minus 3, the 3's cancel with the 9. The 9 becomes a 3. The 3 becomes a negative 1. I go minus 2 times minus 1 is positive 2. And the denominator is a 3. So I get y minus 1/3 equals minus 2/9 x plus 2/3. And then plus 1/3 plus 1/3. That gives me y equals minus 2/9 x plus 3/3, and I would change that 3/3 to a 1. So my answer for 50b is y equals minus 2/9 x plus 1. When I wrote these problems, I tried to make them at some level not grungy. There are definitely grungier problems that I could have snuck in here. Alright, so I'm fixing a mistake. The first time I did problem 52a, I made a mistake. The mistake that I made is I forgot to keep the 4 in my algebra. I did perfect algebra, but I forgot this 4, which makes my work nonsense. So to do part A, I want to find the slope of the line, of the tangent line, for the given value of x. And to do all the part A's, I find the derivative, and then I'm going to plug in the value of x into the derivative. So I'm not going to work with the 9 for a second. The first thing I need to do in part A is to find the derivative, because the derivative is a formula that helps me find the slope of the tangent line at any value of x. So the first term, to find its derivative, I'm going to multiply the exponent by the coefficient, and that x had a 1 that's imagined in front of it but not written. So its derivative is going to be 1/2 times the coefficient of 1 that was assumed to be there but not written. And then I'm going to lower the exponent by 1. And instead of going minus 1, I'm going to go minus 2/2, just because it'll make it easier to do the next step. I'm going to bring down this minus sign, and then I'm going to take the exponent, negative 1/2, multiply it by 2 to take the derivative of the middle term. So I'm going to go negative 1/2 times the 2, x to the negative 1/2, and again I need to subtract 1, and I'm going to subtract 2/2. Kind of didn't leave myself a lot of room, so I'm going to put this plus sign under this, and I'll make myself more horizontal room next time through. Do the derivative of the third time by taking the exponent, negative 3/2. I'll multiply that by the coefficient 4, and I'll lower the exponent by 1. And just like the other three terms, because their exponents had fractions, I'm going to minus 2/2. Now I'm going to do the multiplication I need to do and work on the exponents. So I'm going to get f prime of x equals, in the first multiplication I need to do 1/2 times 1. Anything times 1 is itself, so I get 1/2. And the exponents I need to work with are 1/2 minus 2/2. And when you're subtracting fractions, you just subtract the numerators and you leave the denominators unchanged. So 1/2 minus 2/2 is 1 minus 2 over 2. That's going to be negative 1/2, which is going to be the exponent of the first x. The next multiplication I need to do, I'm multiplying two negatives, so I should get a positive. And the multiplication I'm doing is 1/2 times 2. And 1/2 and 2 are reciprocal, so they multiply out to be 1. I can write a 1 as my coefficient, or I can leave my coefficient blank. I'm just going to leave it blank because I don't need to leave the 1 there. For the exponents, they're a little bit trickier. The exponents here are negative 1/2 minus 2/2. To get the exponent on the middle term, I need to go negative 1 minus 2 over 2. Because the 1 and the 2 are both negative, I'm going to add those numbers and keep them negative. And the exponent I'm going to get is negative 3/2. So the middle term has a coefficient of 1. I'm not going to write the 1. The x base stays the same, and its exponent becomes negative 3/2. For the last term, I need to multiply negative 3/2 times 4. I could be lazy and do that on my calculator. If you want to, you just go second quit, parentheses negative 3 divided by 2 times 4, enter, and then it comes out to negative 6. So instead of writing a plus a negative, I'm going to write a negative 6. And for my exponents, it's negative 3/2 minus 2/2. It's going to be the same as negative 3 minus 2 over 2. And the exponent on the x is going to be negative 5/2. That's the derivative. Probably would be nice to write it at least with positive exponents. So I'm going to go ahead and do that, write it with positive exponents by bringing the x to the negative 1/2 into the denominator with the 2, by creating a fraction for the x to the negative 3/2 to go into the denominator with a 1 in the numerator, and writing the x to the negative 5/2 underneath this coefficient of 6. So that is the derivative written without radicals, but because the initial problem didn't have radicals, I don't really think I need to have radicals. So now I'm going to find the answer to part A, find the slope of the tangent line at x equal to 9. To do that, I'm going to find f prime of 9, which is going to be 1 over 2 times 9 to the 1/2 power plus 1 over 9 to the 3/2 power minus 6 over 9 to the 5/2 power. And I don't really want to do that by hand, so I'm going to do it on my calculator. It's going to involve quite a few parentheses to do it properly. So kind of watch what I enter here if you don't want to do this by hand. So first fraction is going to be 1 divided by, and then 2 times 9 to the 1/2 needs to go in a parentheses in the denominator. So 2 times 9, up arrow. I'm going to do 0.5 for 1/2 just to make it a little bit easier, because 1/2 is equal to 0.5. That way I don't have to introduce more parentheses because of the fraction exponent. So that's the first fraction. That's 1 divided by 2 times 9 to the 1/2. I made 1/2 into 0.5. For the second exponent, 3/2 is 1.5. I'm going to use that rather than 3/2. And for the third exponent, 5/2 is 2.5. I'm going to use that for the exponent instead of using the fraction exponents. It makes it easier on my calculator. So I'm done with the first fraction. Into the second fraction, I do a plus. The numerator is 1, and then divided by Because the denominator is just a single term and it doesn't have a multiplication, I don't really need a parentheses, but I'll put a parentheses to be safe. Go 9 up arrow 1.5. That ends the second fraction. I'm going to put this minus sign, and then 6 divided by, and then parentheses 9 up arrow 2.5. My best guess is that this is an ugly decimal, 0.1790. I don't like that so much, so I'm going to math, enter, enter, and I get 29 over 162. There's a real easy way to check whether you're right or wrong, and I'm going to do that just to be safe here. So, because I'm fixing a mistake, I don't want another mistake on my video, and I can find out that the slope, if my slope of my tangent line has the right decimal. And the way I would do that is go to the y equals, enter the original function, which is x up arrow parentheses 1 divided by 2 minus 2x up arrow parentheses negative 1 divided by 2 plus 4x up arrow parentheses negative 3 divided by 2. So graph the initial function before you took the derivative. I don't know what I was graphing previously, so I'm going to hit zoom in standard to get a decent window. And what I'm going to do is do second calc dy dx. I'm going to type in x equals 9, and I'll know my answer is right if it gets 0.179. So I'm going to go second calc dy dx. You don't have to check to see if your answer to part A is right, but you can. After I select dy dx, I'm going to type x equal to 9. When I hit enter, it's not going to give me the fraction 29 over 162. But if my answer is correct, I'm going to get 0.179. And I get exactly that 0.1790123.5. If I went back to the main screen, I think I'll see exactly that number again. So those are essentially the same, at least close enough to the same. My calculator does some rounding. It doesn't do exact calculus, but this is right to 3 decimals, so I'm feeling really good about my answer to part A. Now I'm going to move on to part B, and when I go to do part B, I need to find an equation of a tangent line, and to find an equation of a tangent line, you need a point and a slope, and what we have right now is a slope and an x-coordinate of a point. So the slope is the answer that I got when I did part A, is 29 over 162. The point I need has an x-coordinate of 9 because that's the given value. To get the y-coordinate, I have to take 9 and plug it into the original function. So to get the y, it's going to be y equals f of 9, which is going to be 9 to the 1/2 power minus 2 times 9 to the negative 1/2 power plus 4 times 9 to the negative 3/2 power. I can find the decimal correct answer by going to my calculator and going second calc value, type in the number 9. The decimal equivalent of what I'm going to get on my calculator is 2.48 rounded to 2 decimals, but that's not a satisfactory number, so I'm going to get the better version of 2.48 on my main screen by doing this computation, going 9 up arrow parentheses 1 divided by 2 minus 2 parentheses 9 up arrow parentheses negative 1 divided by 2 plus 4 parentheses 9 up arrow parentheses negative 3 divided by 2. I better get 2.48. I get exactly 2.48. So I'm confident I entered this properly on my calculator. Now I just need to get the decimal equivalent of this by going math, enter, enter. The decimal equivalent is 67 over 27. And what I've just found is the y-coordinate of the point that I'm trying to find the equation of the tangent line for. So now I'm going to finish up by going y minus y1 equals m times x minus x1 And I'm going to change the y1 to 67 over 27. I'm going to change the m to 29 over 162. And I'm going to change the x1 to 9. So that's the equation of the tangent line that I need in part 52b. I'm going to improve upon this by clearing the parentheses. The easy part of clearing the parentheses is going 29 over 162 times x, because that's just going to be 29 over 162x. The hard part of clearing the parentheses is going 29 over 162 times minus 9. I'm going to do that on my calculator. So I don't care to do 29 divided by 162 times minus 9, which is that multiplication. I don't care to do it without my calculator. So I did it on my calculator, and then I math entered, and that gives me minus 29 over 18 after I clear that parentheses. I'm almost done. To finish up solving for y and get my answer to part B of 52, I'm going to add 67 over 27 to both sides. And then whatever this comes out to be will be my answer for part 52b. On the left side, the 67 over 27's cancel, so I'm left with a y. On the right side, the 29 over 162x doesn't get impacted by this. And again, I don't care to do this by hand, so I'm going to do this on my calculator. I'm going to go negative 29 divided by 18 plus 67 divided by 27. Gives me an ugly decimal. I hit math and enter twice. Gives me the denominator of 54 that I would have had to find by hand if I wasn't using my calculator, and I get 47 over 54. So this would be the answer to 52b. So that's the end of this part of the video. I think there's a part 3. So go ahead and give 51 a go, and then you get to do part 3. I think there's a part 3, but I could be wrong, but I'm pretty sure there's a part 3.